Okay, so let's discuss about some of the corporate level big data solutions that we have. Again, those are mostly Hadoop is the core part, big data is the industry as we have talked about. So as you can see that the overall big data ecosystem that we have talked about have some of the core components like streaming, HBase, Hive, Pig, and some other components which we at least mentioned in the discussion like Zookeeper, Avro, those type of components. They are all open source and they are created by different companies. Cloudora has started projects like Flume or Impala and all those things. So again, different vendors are offering these days different components around Hadoop to solve the problem coming out of the big data industry. As you can see that the first important challenge or configuration or activity that you do when you go into organization is to define this aspect, because different organization will have different meaning of the context in which they are using big data. So whenever in a layman term, big data from any company perspective is that particular type of problem domain wherein your conventional database or data warehouse type of systems are not suitable enough or are not I'll say sufficient enough to cater to the requirements that you have, and that is more around your data mining and those type of thing from analytics perspective as well as also from storage perspective. So different companies depending upon their size and all will have different benchmarks for it. And as it said that big data problems that vary from different aspects, from the volume that is coming in as well as the rate at which the data is coming in as well as also the variability, the different types of solutions and all. So keeping that in mind, and we have also seen the Amazon cloud model that you can do in-house deployment or configuration of Hadoop on a simple cluster or a node in a virtual machine type of environment, as well as you can pretty much give all this responsibility and well, like you can just export all these things out there in cloud and you can use inbuilt Amazon Elastic Map Reduce and those type of solutions to get a ready to use framework. That's something which helps get the at least reduces the overall setup time, and you can directly do your data mining or the logic processing. Now in most of the time when you go for any integrated approach across organization, just a simple Hadoop implementation might not be sufficient enough. You will have to go for many ad hoc or ecosystem types of project to cater to or suit the configurations that your organization has. If you are primarily a data warehousing organization, given the skill set that you already have will be around mostly databases, so you might have to use a combination of Hadoop or Hive in that sense. Also, if your needs are of data storage are in a manner wherein you are mostly accessing the data in a random manner than in a sequential manner, you might as well want to go for a HBase type of solution. And also that's something, those are things which we have talked earlier, that these solutions can be combined. If you or if in your organization there is no Java presence and you still need high level of processing, you will have to look for fast implementations like your Apache Pig or some sort of a streaming option. So you typically go have a Hadoop basic installation done, but whenever you start going more deeper in terms of looking for a technology to write your jobs and in a most, I'll say, easy manner at your organization level, you look for these ecosystem projects and commercial offerings as well. Let's talk about some of the integrated product that we have, because in Apache, that overall Apache ecosystem, if you look, it will have many different projects going on, but different vendors over a period of time have started offering different competitive products and packages. They call it as appliances, and that's where they give the support, the whole open source type of distribution model, wherein the product is free, it is the support which you pay for. A good known example or offering is from EMC, that is the EMC Green Plum. Therein they offer, that's the integrated package that they have for the big data solution. They offer database as their green plum database. For deployment options, they will deploy or give the solutions at your basically Linux and all level. And the Hadoop bundle which they distribute consists of your core Hadoop, Hive, Pig, Zookeeper, HBase and other NoSQL components. So they try to integrate that particular thing, that they have a Hadoop based distribution in a packaged manner, and they also have the database offering combined as a offering in terms of an appliance. That's where it gives some more details around this one. So they have taken basically all these open implementations of Apache and packaged them in a specific manner. And and EMC being a major player at the storage level definitely have vested interest in terms of going more deep into the big data type of solution and be a important player at the storage level, because that's one important aspect which your HDFS tries to solve and all. Now again, this talks about what is their unified analytics platforms comprise of: the database, Hadoop distribution and the HD solutions on it. But this is again when you go into like proof of concept type of modes, and when you invite these vendors to show the capability from a corporate offering, you will get these as a most viable options which are available in the market. So that's the purpose for discussing that. At least you know that Hadoop in its core, when you go in real time, you are not going directly to Apache and downloading and doing everything on your own. You have some good options available which you can use and make it more faster and all, the way typical open source distribution works. So EMC Greenplum is a good option. EMC is a major distinguished player in the storage domain, and they have this corporate offering for Hadoop bundle solution. IBM, of course, being a major player in the whole distributed and software industry, has their packaging which comes in the form of InfoSphere. So IBM InfoSphere is around that particular solution, wherein they offer the database as DB2, and their deployment is again at Linux level, and they also model or often a cloud model, what they call as IBM Blue Cloud. So they have a cloud offering as well as enterprise Linux level offerings also, which is available. So most of these things you will see, except for the Microsoft guys, they offer it as a Linux based solutions. The distribution of IBM, the InfoSphere distribution, will have your basic Hadoop, as well as it will also have your Hive, OZ, Pig, Zookeeper and some of these components. So try exploring some other ones, as we talked about that. You have a Zookeeper which talks or takes the responsibility of inter-process communication across nodes in that particular framework. OZ is something which will be used for workflow management. It's a project or a component developed by Yahoo, just like your Apache Pig component and all. Flume and all will be something which will be used for your distributed log processing in terms of capturing the log from multiple different systems and then doing a common processing, and also Lysine, NoSQL and other things are always available. So IBM is a good and established player there, and you have a good integrated solution there. InfoSphere Big Insights is a Hadoop distribution. So basically this is what you will see, that they are all wrapper around initial Hadoop distribution. So rather than the core Hadoop download, you will download their InfoSphere package, and that will come with all these components inbuilt. It's exactly similar to, for those of you who are in the industry, like the Eclipse solution which IBM uses and offer RAD on top of it. So Eclipse is free. IBM has used the Eclipse infrastructure, everything, and then they have built earlier the WebSphere Studio Application Developer, and now they call it as RAD, Rational Application Developer. So RAD is a paid product, whereas Eclipse is a free product. So that's something which they uses. Again, IBM offers you the GQL. That is something which gives an integration between Hadoop and other IBM products. It's a relational database like DB2 and all. So whenever you get corporate solutions from these vendors, they will give you some integration mechanism by which you can integrate with their existing technology which they offer. So I will be sharing this document, have a read of it, and at least go through these individual sites. All these are individual links to their site. It just gives you at least a Hadoop person, when you know and you claim that yeah, you know the different components and all, at least knowing the different competitive offerings is there. But all these are Hadoop offerings. In a while we will see the competitor for Hadoop also, which tries to do typically the same thing which your Hadoop is doing. But these are all Hadoop's distributions at a corporate level offered by major organizations. So once again, because this is a big hot technology which is coming in and a lot of people have vested interest, Microsoft does have a good support available to use this component. Although Hadoop is primarily at a Linux level, but you can use Hadoop in Microsoft base line of products also. That's where you will have SQL Server as the database. In terms of the options for deployment of Hadoop, you have Windows Server. You can do that, as well as Windows Azure Cloud Model is something which you get that option to create a Hadoop cluster. That is something which will always be available to you. It's exactly similar to your Amazon Elastic MapReduce model that we have seen earlier. Windows Azure Cloud, Microsoft has this Azure Cloud wherein you can request for a Hadoop machine as well to be started with. So their bundle basically have this component and they package Hive and Pig in that particular part. And this is where for all the .NET people and all, it offers you a very simple C# or C# based integration. So you, instead of using your Java language, you use the C# and all to write jobs and then use the streaming API to deploy them. Again, for connectivity to your SQL Server and all, you go down to the low level basics. In Java, you are offered the JDBC protocol by which your Java programs connect to the database that you have. Microsoft itself is into that domain, so it offers you the ODBC connectivity so that you can connect to its SQL Server database and all that type of thing. So all those basic components gets used here. And when you go into Azure model, as you can see that Visual Studio and .NET integration with Hadoop is also provided. To try exploring that solution. It's a paid product. I think you get a 3-month initial evaluation version of Azure, and during that time you can practice and get a high level understanding of what is the ecosystem and all. But this purpose here is to just let you know that different players, major competitors or major companies are into it. Hadoop is not just at Apache level. It has its corporate solutions which you can choose, and you can still convince your leadership, those who are skeptical about how much support or matured it is or what type of support you can get if you run into issue. Rather than going for just standalone Apache Hadoop, you can have these different offerings from these corporate vendor as a viable options, which guarantees that it will be having, at least you will get good production level support and all. Oracle, being now a key software player, has its own offering at that particular level. So once again, it also gives it as an appliance based thing wherein it offers you the Cloudora distribution of Apache Hadoop, as well as it gives its own. So in this case, the database is not Oracle. It gives the Oracle NoSQL database. Oracle has this additional NoSQL database as well. So that's what Oracle tries to offer there, but it definitely has many other components which makes it with, like, yeah, where is there, which is helpful for your cloud-based deployments of your clusters. That's there, as well as Mahout is there, which is for machine learning type of capabilities and all. So these are some ecosystem level projects which you can explore to get more detail. But As you can see, the different vendors have started offering it in a more commercial packaged manner so that you use that particular thing. To read about that, at least you will get some good insight level detail of the same technologies, how they are offered at corporate level and all. Oracle NoSQL database as well as R Enterprise, they are also commercial offerings from Oracle which integrates very well with their Oracle Big Data appliance. These are some analytical databases which are offered at Hadoop level for doing your massively parallel processing type of capabilities. And you will see that the major vendors in that domain are once again the key players: Teradata, EMC, HP. They have over the years acquired those type of databases and which are used for these type of high volume processing so that they can integrate it with their Hadoop solution and offer it as an enterprise offering. So Aster data, this is something which you get from Teradata. So this is where you have this deployment model, the MPP analytical databases. Aster data is one such component. Paracel is another one. And these are all having this different differentiation, as well as Vertica, which is owned by your HP. So Dell, HP, they all have their offerings. If you look into their sites, the cloud offering or the big data solutions, so they do give their solutions using some commercial products. So they will use Hadoop and all, but they will have all these databases also offered there, apart from the core ones that you saw, like Microsoft giving you SQL Server and all. But SQL Server and all, those are all RDBMS. When you get these type of MPP type of databases, you can use them. They are all NoSQL inspired databases, so you use them to integrate well with your Hadoop type of appliances. It's just that at least be aware about these technologies in some or other way. They do have a good relation with the existing Hadoop and MapReduce components where they help it out. Now again, so those are like different big companies who have some major products in different domain and who also have a parallel offering in these Hadoop related big data type of solutions. But over a period, there are some companies which also have evolved, which are specifically focused around Hadoop and its distribution. The very known one being the Cloudora company. It has different certifications, as well as Cloudora Manager is a good, easy to use package application deployer for Hadoop in a clustered mode. You also see many of the projects these days, ecosystem projects like Impala, Flume and other things also getting started by Cloudora. So Cloudora is a good startup from people from Yahoo and other companies, and they are all centered around the Hadoop based distributions. Again, needless to say, you can explore more on it once you go on Cloudora solution. It will all talk about the different things and all, and a lot of good articles and learnings on their site around these individual technologies. So that's something in a Hadoop world. It's good to keep checking their webcasts as well as some of the articles that they keep publishing. It's good insight into some of the real-time challenges that we have. Hortonwork again is a parallel company in that same domain. It also has a good reputation in Hadoop based deployments and configurations and all. One other thing which I have not mentioned is there is a MapR distribution available also. So Cloudora, Hortonwork and MapR, these are three major companies which are focused around Hadoop and its ecosystem projects, and some very good distributions that they offer. In cloud or Amazon cloud based model, you will see MapR has a good, all the Hadoop EC2 instances that you get, they are all MapR instances and all. Similarly, the open distribution that we got from Apache, you will see there is a most of the components, at least the web parts, web components have been developed by Hortonwork. That's when you start those processes, it in the UI it tells you that this is something from a Hortonwork thing. If you integrate with components like Apache, Flume or Impala, you will see it's getting developed by Cloudora. So these three companies are major contributors. There are other many startups which are coming around on these particular Hadoop and its overall ecosystem related projects. Now this is one important thing that we know, that again, though dominant, Hadoop is not the only big data solution. It's just that Hadoop is the most common and implemented one. Your LexisNexis HPCC is also an alternative approach and all. That's a competitive product to Hadoop. So all that we saw right now was that different vendors offering their packaged solutions around Hadoop and the support model and the other integrations that they have with their existing products. In terms of a total competitor to Hadoop, you will have to evaluate the HPCC solution for that particular need. Now try going on the HPCC website to have a more insight into their solution, but I thought that we can still have a small comparison report. This is something which is pulled out from their site itself. If you go on to their system, they do try to compare it for the sorting algorithm, which is a benchmark for all these big data technologies. How fast you can do a 10 terabyte data sort or a 5 terabyte data sort. They try to measure that in the number of seconds, and that's what checks the overall efficiency and all part. But these are some high level comparison between HP CC as well as Hadoop. So again, this is something which HPCC has produced, and you will see that HPCC in many ways superior to your Hadoop based solution. It's just that it's a paid product. But a good thing is that it also has a specific VM which is available, so you can download that VM and practice the same and do just some hands-on on that particular part. So both of them are available in terms of their distribution and all. Just tells you that Linux and Windows, both versions are available for both these systems. Internally you will have a different configuration or the core product that you have. Now Hadoop architecture is more around name node, data node, task tracker node, and job tracker. In HPSSCC you will have different types of terminology. Your Thor cluster is what they typically configure, as well as also a Roxy cluster. So these are terminologies which they use to configure the parallel single node as well as multi-node type of distributions and all internally. This was something which we still wanted to talk about in terms of the competitors, so that you have a good idea about the parallel solution which is HPCC that is available. And as you will see that the type of claims that they have is that they are, at least for a 10 terabyte type of data, they have better performance compared to a Hadoop cluster utilizing the same hardware and all. This just talks about some of the internal component. You will always find their alternate language like pig and all, which you use in Hadoop to write your jobs. You use ECL there, which will be used to define the logic or the jobs there, which you will run on the Thor or Roxy clusters there. So evaluate that. I'll share these docs with you, and these are all available over internet as well. It's just that you just have to do that research, and once you get that pointer, you can start at least evaluating. And as a Hadoop person, you should be knowing some of these competitors which are available to get a good benchmark of what's happening on their side and the options they are coming up with. Ease of deployment, all these, this is just a configuration thing which it talks about. So go through it when you get some time. This is a good comparison between HPCC and Hadoop of how the internals work with each other. HPCC is still at a very, I'll say, startup level, so that's not a big threat or a challenge to Hadoop based solution, and the companies have embraced Hadoop in such an extent that it seems hard that in future also you will have much more investment at HPCC level. But yeah, many research projects and all which go for high volume types of data processing are executing these days HPCC based clusters itself, government funded organizations and all. So these are just some high level details around it. You can go through it and take a look around some of those capabilities. Yep, I know you will have less options coming in. It's just that it's good to know that who are the competitors in the market, and that's what you benchmark. You can see here that the performance thing, it tries to say that it's around 4 times faster than what your Hadoop does at the same benchmark level. They have it at 1 terabyte for 400 node system. That's what they were able to do in 102 seconds, whereas the same thing on 1400, around 1500 nodes was done in 62 seconds. So that's where they try to claim it out. This is a good site actually. Try to go on this sort benchmark. This is a key industry benchmark or a practice which people try to do whenever supercomputers comes and new people claim that they have the fastest processing capabilities. You normally compare the data that you have at sort benchmarks to see that how much is the improvement or has the improvement really happened and what factor is the one that is coming in the overall comparison. So try that out. It's something for, I thought that it's good for us to share it. At least you know the competitor, you know that Hadoop is not the only person in the field, although it's the most dominant one. You also by this time know the corporate offerings that you have. So you are not just alone in terms of implementation, that you don't have any corporate level support. You can buy these appliances from these individual vendors. Microsoft, Oracle, EMC, HP, Dell, almost every vendor these days have some sort of a appliance or some sort of a tie-up with the original companies to give you an integrated product. Standalone also, if you want to go for more dedicated and long-term strategy, it's always recommended to have either Cloudora or Hortonworks people come in, analyze your infrastructure and then come up with their suggestions. And based on your knowledge as well as the type of details that they need, you will be able to share them with more practical details, and that will help you configure a better ecosystem for the end-to-end Hadoop installations. So this is where we'll talk about some of the hardware-based configurations that are recommended for Hadoop-based solutions. But as I said, that deciding on a specific hardware or a specific configuration is very difficult for Hadoop type of thing, because you always go with a specific set of requirements in mind, and it depends a lot on like what type of processes you are planning to run, what is the overall complexity of your map and reduce, what is the overall data that needs to be transferred between nodes and all. So depending upon that, you will see that whether the priority needs to be given to memory or the overall hard disk or the network broad bandwidth. So depending upon different types of need, you will have the focus changing, but all of that is configurable. We have seen in the past that your MapRed site, that XML as well as the HDFS site, you can configure those properties. So this just talks about that particular infrastructure itself, that typically how you can have a large distributed type of architecture wherein you have name nodes and slave as well as data nodes running in that particular type of architecture. Rack awareness is something which we have talked about earlier, that you need to configure a specific rack script and provide the topology script in your hdfs-site.xml, and that's what will be used by Hadoop to decide which IP address to use to make the next copy of a block. This is just a high level diagram of how a typical cluster will look like in that one. Region servers is something we talked at the HBase level, that HBase master server combination is H master and your region server. So that's the master slave configuration there. And in an infrastructure, it's very good chance that you will have these different ecosystem projects coming in. You can see that one rack here is, you can see, is dedicated to all your master processes, wherein one virtual machine or one VM is occupying name node, one secondary name node, one job tracker, and one the HBase master, if assuming that you have Hadoop and HBase configured. On all other systems, you have individual slaves running and all. And when we say slave nodes, assume that you have the task tracker and the data node processes running on those systems. And this is how you typically configure them at a rack level. As I said, that your disk space, IO bandwidth, and the individual CPU RAM will be the most important parameter that you have to provide for your hardware sizing. But just like those of you who have real-time experience of doing hardware sizing, it's almost impossible to do that analysis in first go. You always go on some guesstimates that this is the high level thing and this is what we'll be needing. Mostly you plan always for over capacity, then under capacity, and then later on you fine tune it, and whatever is the redundant one, you just take it out. Same thing you will have to do for Hadoop as well. And as I mentioned, that at Hadoop, you will also have to see that what type of jobs or processing that you are going to do. If your data is small, but your a good example is your data is small, but your processing is like a simple example is you are going to do a sentiment analysis on Twitter feed or some of the Facebook likes. Therein you know that it's the volume which is going to be more, but the computation is pretty easy. You have a specific set of keywords which you have to find in the data which you have got. So at that time, your hard disk capacity becomes more important. If the other part is that you have a small amount of data coming in, but you have to do complex logic processing on that data in order to find the relationships and then look for specific patterns. Like suppose you are doing or trying to solve some computational algorithms like traveling salesman problem or your graph theory related problems. So therein your data set could be very less, some 6 or 7 node directed graph, but the number of permutation combination that you have to do, or you are trying to do a vector to vector product, those type of mathematical analysis things where the data set is less but the computation is very high, you will have to then start focusing your hardware around the processing power of your name node and data node. So that's where RAM and heap memory and all those comes into picture. Now it might happen that you might also get situations wherein you have to do parallel, I'll say chain processing of your jobs. So one job runs, the output of one becomes input of another, and so on and so forth in a streamlined manner. So if that is the thing that is coming in, then you also have to start that case when your one job completes and becomes an input for another job, basically job chaining, you know that there is going to be a lot of data transfer across your map and reduce processes, and that's where your gigabyte Ethernet capacity in terms of how fast your data can travel from one node to another node becomes a major critical factor. So depending upon what is the focus, you will plan it out. You will always go for some default implementations, but this is what actually in real time your discussions with your Cloudera or Hottentot expert will also put in. At least the experiences that I have, they do try to analyze the requirements that you have and try to map it out with the solutions that they have and do the high level capacity planning for you. Same thing, it's putting it computation intensive, IO intensive, or if you don't know the type of work pattern. So you have to analyze that detail and then do a guesstimate at high level that what should be the priority of your deployment. Once again, I'll be sharing this paper. You can download it also, not something which it's all available on net. You just have to go through it and take a high level guess and take it up. As well, we talked about that these days almost all the CPUs that are coming are quad core. So dual core and all are anyway phased out. You go for quad core so as to do multi or high level threading and parallel processing capabilities, and try to have, as I said, that maximum amount of RAM available and have dedicated boxes for your master processes. That always helps out. 1 GB gigabyte Ethernet is the default speed, at least that networks are requesting for a medium or a small level Hadoop cluster. But the more network speed that you will have, the better will be the inter-process communication and the data copy from one system to another system. Again, this is Hortonworks, so they try to sell their own concept, but again, you can get that support from Microsoft people, whoever, Amazon Cloud folks. If you're using EMR, they will help you do that planning and how much you need the capacity and all that stuff. So this is just talks about those things. I'll think once you read about it, it will make more sense to you guys, because many of these terms are totally alien to people, those who have never done any capacity planning or have not been in discussion with network folks or external consultants in terms of the capacity, RAM, monitoring, and those type of needs. But those of you who have some experience, read about it. Even those who have never done, try to read it. You will always get some good thing out of it. But some of the key things that keep in mind, that capacity planning in Hadoop is no different from what you do for any other hardware type of needs. It's just that in Hadoop there are different aspects. So you have to fix those priorities, analyze the business problems that you are going to use or solve through your cluster, Hadoop cluster, and then take a call. That is something which will be helpful to you in long run. So read about these papers. It will be something which will be for your good itself. It tries to use some specific network-based technologies which I think will be known for some people, like SATA drives and all those things, for EMC and all those hardware folks. It will give some sense. Down below it gives you more specific things around the memory provisioning, the type of RAM, DRAM, 3 or the other ones that you can use, power considerations, because that is also an important criteria. You should not end up utilizing a major amount of power itself. So what are some of those criteria around network building? Talks here about your networking needs, what type of gigabyte Ethernet type of connections will help, depending upon the node and the distribution and all that part. It's a good read. I thought that it's good or worth sharing with you guys, so that once you read about it, you'll get a good level of idea. For those who are into hardcore admin type of, this is mostly for admins as well as primarily for architects to take a high level call and provision an initial environment and then take a high level thing. So this is where it talks about the workload pattern, the type of storage which you might need, the type of processor, and the memory for a small cluster, 50 to 5 to 50 or 100 type of nodes. For a medium to large cluster, that is still 1,000 range, this is how the growth could be from a storage, processor, and memory perspective. And you also have, it just talks about for the master and the slaves, because for each of these you have these master and slave configurations, and then these individual pointers, you can go through it. We have some. So take a read of this one. This is something for your good itself. I'll also be sharing one more paper. This is again inspired from one of their discussions where they talk about on CPU, on power or RAM, what type of decision on disk as well as on network, what type of decision that needs to be taken. So these are just some high level discussions around the switches, rack spaces and all that thing. But overall, you will have to talk to your network people or those who are in capacity planning to bind the fact whether you go for a HP boxes or Dell boxes, and the type of RAM, quad core, what type of processor you are using, as well as the memory distribution and all. You can always change it later, but it just depends that in the first go you will try to make it more uh, close to your actual deployments, your RAID based type of disk storage or your EMC SAN type of storage. All those decisions comes in. It's a hardcore hardware related discussion. It's not a part of Hadoop, but overall capacity things, since you're talking about cluster and all, it does comes into picture, and that's where these things, once you read it, will help you out take a better decision. So please review the same. I'll be sharing with you these things, and just let me know if you have any questions on this one. We'll definitely try to discuss the same. Thank you.